Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Objective for our lesson today, we're going to look at the last 3 types of fault. Yesterday we looked at the 2 examples, and the 2 examples we looked at were those of the normal fault and the reverse fault. And today we'll go ahead to looking at the 3 other types of simple fault, and they are the thrust fault, Graben, and Horst's. We'll go through, or I'll go through the explanation of those 3 simple faults with you later on, but we'll start off our lesson with revision on what we have covered on those 2 simple types of fault yesterday. Okay, making reference to the information from the monitor, we have an example of a normal fault, and from what we have covered on the normal fault, trying to recognize the difference between a normal fault and a reverse fault, what would be some of the characteristics that you could look for to help you distinguish the difference between a normal fault and a reverse fault? What would be a characteristic, or what would be a main feature that you might look for to help you identify the difference between those 2? Dorothy, this is revision, what we have covered. What could be a feature that you might look for to help you distinguish the difference between a normal fault and a reverse fault? Dorothy is still thinking? Let's go quickly.
A normal fault, that tension force is applied on it, and yeah.
And the reverse fault?
Reverse fault is compression.
Okay, so one of the things that maybe you could look at or look for in the diagrams would be the forces. And the forces of tension will tell you it is a normal fault. The forces of compression would be a reverse fault. Okay, besides looking at the forces, what else could you look at to help you identify what type of fault is actually displayed or shown? Shelley.
The strata.
Would you like to explain a little bit more on what you mean by the strata?
The displacement of the layers.
Someone would like to help Shelley on how the displacement of the layers can help you identify the difference between a normal fault and a reverse fault. She's definitely correct to say that the other feature that you can look for to help you identify the difference is the strata or the different layers. But what is it that you look for in the different layers to help you identify the difference? Catherine?
A normal fault is created as a result of tension, where one strata is forced downwards and the other is forced upwards.
How about the reverse fault?
A reverse fault is when those on one side of the fault plane right up over those on the other side.
Okay, so the point made there is basically looking at the displacement. In a normal fault, one of the layers simply slides down or up along the fault line, whereas in a reverse fault, one of the layers overrides the other layer along the fault line. And that is the difference, the second difference that you can look for in trying to identify the difference between a normal fault and a reverse fault. Do we understand those 2 features that we can look for? Okay, good. If we can understand those, then those would be the 2 main areas that we try to pick up when we look at diagrams or when we look at photographs or pictures, and we can identify by looking at those information. Today, I'd like us to move on now to looking at least one more example, and one more example of looking at normal fault. You're going to sketch the information, and it should take you at least 5 minutes now that we have done some practice already. And the area or the section we are moving to is again revision, and after we complete the revision and I correct the activity with you, then we will move on to looking at the 3 other types of fault that I would like us to look at for our lesson. Here we have an example of a normal fault already explained. We look at the displacement, the way in which the layers of rocks have been displaced in relation to each other. We also note that the force is tension. The second diagram shows us an example of a reverse fault. We've looked at the displacement whereby one block overrides the other block along the fault line, and the force which is exerted is forces of compression. And here we have an example of a reverse fault. Okay, we go ahead now to doing some more activities in sketching, identifying fault lines, and as well as that, checking out the displacement in terms of how the layers or the strata have been displaced in relation to each other along fault lines. Look at the photograph or picture shown on our monitor. We study that and then 4 lot of activities. It should take us only 5 minutes for the completion of the activities. Can we see clearly from the back the photograph shown? Yes, okay, good. Activities. I'd like you to sketch that particular diagram, and when you are sketching, you are actually sketching to show the fault line, sketching to also show the strata and how they have been displaced in relation to each other along the fault line. So I'd like you to sketch from that photograph or picture the diagram and show clearly on your sketch at least one strata and how that strata has actually been displaced in relation to the other strata from that particular diagram. Once you have done that, I would like you to also indicate from your sketch how the rocks have been displaced. So you use arrows to show the displacement, and then I'd like you to also clearly label the fault line on your sketch. We have 5 minutes. Let's start, and I'll go through the correction of that in 5 minutes. We will have to check this information, otherwise we will not go over on what I'd like us to look at for our lesson. Okay, we'll do corrections now to that diagram. Remember yesterday I said we were looking at the simple photographs, and as time goes on we got to recognize also as the photographs get a little bit more detail with more information. So if you look at the sketch that you are supposed to have done, how many fault lines does your sketch have, or should your sketch contain? 2 fault lines, correct. So if you look at the information from the monitor and you check your sketch, there are 2 fault lines here. There's one here and one on this side here. How do you know there are 2 fault lines? You can check the different strata or layers, and the layers will indicate to you. Okay, let's check this workout and let's see what you should have. Okay, 2 fault line. Here, one there, one on that side, as shown from the monitor. Note, you were asked to at least label 1 layer or strata. The purple color will indicate at least 1. I've put down 2 there so that we can see in relation to each other the different layers as shown on that particular photograph. So you have on this block here, the far left-hand block, if we had to put in the next activity, and that is the displacement, this particular block here has moved down along this fault line in relation to the middle one. Because the layers will tell you, once upon a time, this layer here was in line with that. Now it is further down in comparison to that. But that's not all. Check the last or the far block. You would have noted that the layer is further up in comparison to the middle block. So your arrows, when you are showing the displacement, you should show the arrows for the first fault line, how one block has been displaced in relation to the other, and then you do the same for the second fault line. You show the displacement, how one block has been displaced in relation to the other along the fault line. So if you look at this particular fault line here, this layer has actually moved in this direction, whereas this one here in that direction. Whereas for the second fault line, this layer here has actually moved in this direction and this one in that direction. Questions? Were you able to pick that up from the information on the photograph? Yes. Yes. Some of you might be sitting there and wondering, could it be possible? Because if you look at the blocks here, you might be wondering, why is it that this block here is one block and this part here is moving up, meanwhile it's one block and this section here is moving down? Are you thinking along that line? Yes. Okay, if you are, then what we are looking at now is an example of what we call step faulting. That diagram is an example of a normal fault, but it is not along just one fault line. You see, when we were looking at photograph of only one fault line, it was very easy for you to identify. What happens if there are more than one fault line? Then this is a good example. It is still a simple diagram because it's only showing us two fault lines. Here we have an example of what we call step faulting. And a definition, a simple definition of what step faulting is it is a parallel series of faults. Here we had two. On our diagram here we had two. We could also have more than two fault lines. What has happened is that with a repeated down throw in the same direction. We all should know what a down throw is. Remember what we've covered on the terms associated with nature of fault? A down throw is simply the area which has been depressed. Okay? So here we have a series of faults. What has happened is simply the blocks have been repeatedly pushed down along the fault line. So we have this layer here being forced down. So along this fault line, this is the down throw. Between this block and that block, this is the down throw. So you can see the repeated down throw along the fault line. And here we have an example of what we call step faulting. And in this diagram, it also shows us a normal fault, but here we have step faulting. That is why when you look at the arrows, you will find out that your arrow for the first block on the far left-hand side is pointing down. The middle block along the fault line is going up. But still on that middle block, when you are making a reference to this layer with that layer, then you will find the layers here have actually been forced down, whereas these layers here have been forced up. And what we are looking at is an example of step faulting. Any questions? Yes, a question at the back. Can you pass the mic down quickly?
Could there be, is there any possibilities for a situation like that, that we can find both a reverse and a normal fault?
Yes, possible. It could be possible whereby you could have on a block faulting, this time I'm introducing the term block faulting, and here we are looking at land area whereby there are multiple faults, and the forces exerted on a particular block may be tensional, and still on that same block of land, the forces might be compressional. Then we could have an example of a normal fault and an example of a reverse fault. We will look at block faulting in our next lesson. So definitely, yes, there could be a possibility for that. But for the case of here, the step faulting, this is mainly to do with the forces of tension. And as a result of the forces of tension, one block is simply down throw or displaced downwards, resulting in the down throw, repeated down throw features being created. Any other questions? No other questions? Okay. Those are activities. Remember I said we are supposed to look at some more activities. It will help us be able to identify faulting, but this time we look at a little bit more difficult pictures of photograph. I hope that is not too difficult. Okay, the answers we have already on the two charts here. And now I'd like us to move on to looking at the last three types of faulting. And the last three types that we are going to look at will be that of the thrust fault. Then we have the graben, and then we have the host. The reason why I'm putting those three together is because when we look at those three types of faulting and you're comparing with a normal fault and a reverse fault, you will find that it is easy for you to identify faulting in those three examples compared to the normal fault and the reverse fault, which is a little bit more difficult to actually pick up in terms of what we can recognize so that we are able to tell the difference between the two. But for the three, thrust, graben, and host, by looking at the diagrams, automatically you can pick up the way in which rocks have been displaced. We'll start off first with the thrust fault. From the monitor, you can see here displacement. Would someone like to explain to us how has displacement taken place for this particular diagram or picture? What type of displacement has taken place for this thrust faulting to occur? Anita, what do you think? What type of faulting? Sorry, not faulting. What type of movement or displacement can you see from this particular diagram on the thrust fault? There's only two types of displacement that we've learned of already. So which one do you think will apply to the thrust fault? Anita?
Horizontal displacement.
Okay, very good. Simple. It's a horizontal displacement. If it is vertical, then it will be one up, one down. So if you look at the thrust fault, if you look at this three-dimensional diagram, you would have seen that the fault line is here along this point here. So look at the information showing where the fault line is. Can you see that? This block here at the top has been actually displaced in relation to the bottom block because of the fault line, which is horizontal. Okay, the forces which is actually added on, you see the forces here pushing this particular layer over the bottom layer. And where we have faults of such, that is referred to as a thrust fault. Let's look at the definition given from our chart, and then we'll go to the monitor. It says here, a thrust fault is simply a type of reverse fault. You already know what a reverse fault is. What forces is exerted for the formation of reverse fault? Compressional forces. So here, obviously, it would have to be compressional forces. It's a type of reverse fault that is characterized by a low angle of inclination with reference to the horizontal plane. The horizontal plane or the fault line, which is horizontal, and the faulting comes about as a result of the top block being pushed over the bottom block along the horizontal fault line. Okay, if we look at the information from, or the definition to the thrust fault again, similar to what I have looked at, a type of reverse fault that is characterized by a low angle of inclination with reference to the horizontal plane. Okay, that's straightforward. Maybe another example, you can put your maybe hands on top of each other like this. The gap or the area separating one of your hands from the other one is the fault line. And if you push your hand back, faulting could have happened similar to that of a thrust fault. Or you could also have a thrust fault whereby the top hand simply moves to the left or to the right. And here we have a thrust fault whereby faulting has taken place. The main thing to look for is the horizontal fault line and the displacement along the horizontal fault line. That's the first one on the thrust fault. Let's look at a graben. The graben is the depressed part of the feature here. But note that for a graben to occur, there needs to be two sets of parallel fault. Two faults to have or to be present for the feature of a graben to be formed. Okay, you have a fault line here, and then you have another fault line there. And the graben, it refers to the depressed area between two uplifted area. So there is two uplifted area could have been formed as a result of blocks uplifted and an area in between being depressed. And then we have a depression then, of which the depression is referred to as the graben. You must have those two parallel faults. Okay, we note the movement of the graben then. You see the arrows there indicate the displacement. The two blocks on the side here have moved up. The block in the middle has actually moved down along those two parallel faults. The depressed area is a graben. We can show that with the illustration from the monitor. If you look at that, originally, note the fault planes or the fault lines. Then we have one block being forced up. That's the one on the right. And then you have the left block being forced up. The depressed area in between the two uplifted blocks are referred to as the graben. Okay, definition to what a graben is. From the chart, it is simply to do with the crustal block of land, the crustal block of land that has been down faulted between two parallel faults. So this area here is referred to as a graben. Sometimes we use the term graben or rift valley. A rift valley, this is an example then of a rift valley and how it is formed. Graben is actually a German term for a structurally defined block of land down-thrown between two parallel faults. So in geography, we can also use the term graben, or we can use the term rift valley. They are referring to the same concept or same term. Okay, so it's simply the down-faulted area between two parallel faults. That's where the graben is. Finally, the last of the examples that I'd like us to look at, and this time it is of the host. By looking at the diagram, straight away you can say that it is the opposite to the graben. So this time the host, we are making reference to the uplifted area between two depressed area. So the opposite now of the rift valley or graben. Okay, look at the arrow. The arrows here indicate the displacement along two parallel faults again, but this time the middle block is actually forced up and not depressed. And the uplifted area then becomes the host. Okay, if we had to look at an illustration of the formation of a host, originally, fault lines are important. Without the fault lines, these features may not be created or displacement will not occur. You have the fault lines occurring there. And then finally, we have the uplifted area. And you can tell the uplifted area by simply looking at the different strata or layers. And you can tell whether a block has been uplifted or depressed. Information from the chart. Definition to a host, it is simply a fault-defined block which have been left upstanding by sinking of the adjoining land along normal faults or has been uplifted along parallel faults. So along the two fault lines, the blocks on the side could be depressed, or along two fault lines, the block in the middle could be uplifted. And that's where we have the formation of a host. Queries? Okay, the definition from a monitor is similar to the information which I have just explained on what is a host or what a host is. Okay, let me give you time now to digest that information, and I would like you to now put into your exercise book construction of at least three-dimensional diagrams showing a thrust fault, showing a graben or a rift valley, and also the diagram showing a host. When you do your construction, what I would like you to also do is I'd like you to ensure you label the parts to the diagrams correctly. And when I say label, I'm talking about labeling in terms of the fault plane, label the fault line. You label the areas which have been uplifted to be graben or depressed to be, the area which has been uplifted to be a host and the area which has been depressed to be a graben. And I'd like you to also indicate the displacement correctly on your diagrams. Okay, I'll give you time now to make note of the diagram. You can use the chart for your construction, or after you copy down the activities, I will put back the information on the monitor for you to make note of. Okay, we've also come to the end of our lesson. You will be required then to complete those diagrams for your homework, ensure that you have that information in your exercise book ready for our lesson tomorrow. Okay, class, if you can now stand up. Okay, to the pilot teachers, our keyword for lesson 49 is graben. Good afternoon and thank you, students.